Hey boys and girls, this is Mr. Bell, Mr. Bell's Math. Today we're going to be talking about writing inequalities. Our essential question, or what I want you to know by the end of this video, is how can you use inequalities to represent real-world situations? Using inequalities, you can use you can use them to describe quantities. And when I'm talking about quantities, I'm talking about stuff with variables or numbers, and they can have many values. Okay, so it says you can use inequality symbols with variables to describe quantities that can have many values. Okay, so when I start talking about this, I'm talking about less than, all right, which some words you might see are fewer than or below to represent that, greater than, which might be more than or above. You might have less than or equal to. That little line there represents equal to. And you might see at most or no more than. And then down here you have greater than or equal to. All right, is greater than or equal to. And you might see at least or no less than. Okay. So here are some examples of stuff that you may be familiar with already. Something you might have seen in the past is 1 plus 1 equals 2. The equal symbol just represents that what's on the left side of that equation is equal to what's on the right side. 1 plus 1 has the same value as 2. Okay. Over here you have 1 plus 1 does not equal 5. And I don't know if you're familiar with the slash through the equal sign, but that represents does not equal or not equal to. Here you have 3 is less than 5. And that's the only way you would read it. You wouldn't read it 5 is greater than 3. You would say 3 is less than 5. You read it left to right. Okay. Now the thing with this symbol is that it always points towards a smaller number. Okay. It's always going to, or it always opens to the larger number. All right. The next symbol is 5 is greater than 3. Okay. That's when you would read it as 5 is greater than 3, when it starts off with the 5, because you got to read it right, left to right. Okay. This symbol, once again, is pointing towards a smaller number, and it's open towards a larger number. Okay, so let's look at this example here. It says Walker is at most 9 years old. Okay, so you would use a variable to represent Walker, and you would say that that W is less than or equal to 9. And all that is saying is that Walker is less than 9, or he can be equal to 9 in age. Okay, so that's what at most means. He's at most he's 9 years old. That means he could be less, but he also could be equal to 9. All right. Oh, I skipped one. All right. Anyway, so let's just talk about graphing these things real quick, because that's going to be the next step is graphing. I think that may actually be, yeah, I put it in the wrong spot. So let's talk about this one, then I'll go back to the graphing slide. Okay, so here's another example. There are at least 50 marbles in the jar. Okay, so that you could represent marbles with M. All right, and you would say the marbles are greater than or equal to 50. Because there's at least 50 marbles in the jar, that's suggesting that there's possibly exactly 50 marbles in the jar. Or when you say at least, you can say that there's possibly more. We don't know, and that's when we use inequalities. We're not 100% sure what the exact answer is. Okay, and there can be a multitude of solutions for this. There could be 51 marbles, there could be 52 marbles, there could be 58, there could be 1,000 marbles in the jar. We just don't know. Okay, so let me go back to this other slide, because we're going to talk about graphing them. So when you see these two symbols here, okay, the graph is very specific. Okay, because you can have a lot of answer choices. How you graph it, let's just say we have a number line, and I want to say that a number is, I don't know, greater than 5. Okay, so I would draw a circle, and then I would make an arrow all along my number line, and that suggests that any value larger than 5 would work for this. Okay, any number larger than 5. We draw an open circle because 5 is not part of the solution. Okay, because if we actually drew a closed circle, that suggests that 5 is part of the solution. So if I said 5 is greater than 5, that wouldn't be a true statement. Okay, so 6 would be greater than 5, 7 would be greater, but 5 isn't. 5 is equal to 5. So since we don't have that equal part on that, we aren't going to get 5 as a solution. Okay, so let's look at another example here. Let's just say that I want to say that a number is less than 5. Once again, I'm going to draw an open circle, and then I'm going to draw a line saying, and this suggests that any value on the number line less than 5 will work for my answer. Okay, any value less than 5 will work for my answer. Okay, same thing we just said before. Now, when we start talking about these symbols here, with the equals sign underneath it, with this little line, okay, our circle is different. If I say something is greater than or equal to 5, I draw a filled in circle, okay, and then my arrow. So the difference is now that I have a filled in circle, that 5 is part of my solution. I can say 5 is greater than or equal to 5, because it's one of the solutions would be that 5 is equal to 5. Okay, so that's how that works. The next one is less than or equal to, so I would draw a closed-in circle again, representing that 5 would be part of the solution, but also anything less than 5 would be part of the solution as well. Okay, so, and that's what we're talking about here. It says a solution of an inequality that contains a variable is any value of the variable that makes the inequality true. Okay, for example, 7 is a solution of x is, and let me rewrite this so you can see it, x is greater than negative 2, since 7 is greater than negative 2. 7 is greater than negative 2, and that makes sense. Okay, if we were to graph it, okay. Now, one thing when we're graphing negative numbers, remember, yeah, so far on all the graphs that I've done, I've just included the number that I'm starting with. But you know, remember that this is negative 1, this is 0, that's 1, negative 3, negative 4, oops, 4, and so on. Okay, so when I say x is greater than negative, or yeah, x is greater than negative 2, I would say, I would start at 2, draw an open circle, because negative 2 can't be the solution, and then anything greater than that. That means negative 1 is greater than negative 2, 0 is greater than negative 2, 1 is greater than negative 2. Any number to the right of negative 2 on the number line is going to work for this situation. Okay, so let's look at a couple and graph them, and then we'll be done with the video. Okay, so I have y is greater than or equal to negative 3. So I'm going to draw my number line. I'm going to put negative 3 on my number line. I'm going to go ahead and put negative 2, negative 1, 0, negative 4, negative 5. Okay, I'm going to, because we have this line at the bottom, greater than or equal to negative 3, I'm going to draw my circle and I'm going to color it in, because negative 3 is definitely part of the solution set. Okay, so then we just draw our arrow. That means anything to the right of negative 3 on the number line is going to be a possible solution. Okay, and then here we have 1 is less than m. Okay, so I'm going to draw my number line. I'm going to draw 1. Oops, that's not a 1, that's a 0. I'm going to draw a 1. Over here would be 0, over here would be negative 1, this is 2, this is 3, 4, and so on. Okay, so it says 1 is less than negative m. Okay, so we can rewrite this to say m is greater than 1. Okay, so that means I'm not going to close in my circle, but any value greater than 1 can be the solution. Okay, so if I said 2, 1 is less than 2, yeah, that works. 1 is less than 3, that works. 1 is less than 0, no, that doesn't work. So I can't have anything this way. That doesn't apply. Okay, 1 is not less than 1, so that's why we draw an open circle, because they're the same value. We draw it there instead. I drew off the page. Anyway, that's all there is to it. So make sure you answer the questions, do your Cornell notes, and I'll see you guys in class.